In this video, we will discuss sensitive parameter control, which is a combination of two processes. This combined process is necessary so that we can avoid several different problems that arise from changing certain types of problem parameters. When all the different problem parameters have been identified and defined, it is important to identify the parameters that are highly sensitive, using sensitivity analysis. In sensitivity analysis, each parameter is individually examined and changed by a certain magnitude. We consider parameters to be highly sensitive when small changes in their individual values have much larger effects on the overall design. The parameter input change magnitude is then compared to the output change magnitude of the entire design, and each parameter is therefore ranked on the basis of their sensitivities. Once sensitivity analysis has been completed, and all the parameters have been ranked by sensitivity, the next step is to analyze all the highly sensitive parameters and figure out the absolute limits for their optimization. This calls forward Pareto optimization, otherwise known as multi-objective optimization, where a series of parameters are compared to each other to generate values for said parameters where the resulting designs are all feasible. What Pareto optimization attempts to do is to find the absolute thresholds for values the problem parameters can take on without interfering in requirements set by other parameters or the design. For example, we can compare the values that a parameter 2 would take on with respect to changing a parameter 1. This relationship between parameters provides a set of optimal design choices on the Pareto optimal front where neither of the parameter boundaries are violated. As a result, we would pick one of the designs and lock down those parameters going forward. Although it is very clear-cut here where the optimal design choices lie, as we involve more and more parameters for comparison, then the Pareto optimal front may not be so clear-cut. In those instances, we evaluate which parameters are more important for minimizing and focus on bringing those as close to optimal as possible and leaving the other parameters not as optimized. To place importance on the parameters, we can use weighting algorithms, but that is beyond the scope of this course, so we will not discuss it in further detail. Now that we have identified and locked down the highly sensitive parameters, we can complete computer-aided engineering using the low-sensitivity parameters during iteration to further optimize the model as a whole. Thank you for watching this video. See you in the next video.